So today we will finish our chapter 3 after 3 weeks kan. I think 3 weeks kot kita start. So this week we will finish the chapter 3. So so we'll still not for today's class. Okay, we teach about this thing. Okay, linear momentum equation and application. And tomorrow we will look a little bit on tutorial for this subchapter, and I will talk about this last subchapter as well, angular momentum. So we'll finish these two subchapter this week. Okay. So before I go to the new subchapter, okay, if you still remember my slide, we talked about 3 different physical laws, which talk about a different equation lah. So one, law of conservation of mass, where this is your continuity equation, and the second one, the first law of thermodynamics, about the energy, and where your Bernoulli equations come. And the last one, okay, this is the one that we will talk today about Newton's second law, and this Newton's second law will talk about the momentum equation, where it balances the momentum inside the system lah. Okay, and if you remember before this, we learn the Newton's second law sama dengan F equal to ma kan. So this is what we learn in school. Okay, but in this subject, fluid mechanics, where we talk about the fluid dynamic, we will alter this equation accordingly lah to what our object is. Okay, now we are talking about a fluid kan. So the object is a fluid, not a fixed object where you have a constant mass. Before this we talk about a constant mass kan, ada bola ke, ada kereta ke, so that has a fixed constant mass. But in a fluid mechanic, the object is a fluid kan, the water or the oil or whatever. So that object don't have a constant mass. Maybe there's a few changes at any point. Okay, so that we cannot use this equation lah. So we will alter this equation accordingly. So we will see after this. Okay. 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 So linear momentum equation and application. Okay, according to the Newton's second law, it states that the rate of change of momentum of a body is equal to the resultant force acting on the body and takes place in the direction of the force. Okay, so the general equation of the Newton's second law is this: F equal to ma. But due to the mass of the fluid is not a constant, okay, it's not a constant mass, so therefore we cannot write equation like this. So this is only for solid body. For solid body, so you have a constant mass, so we can use this. But in fluid mechanics, the mass of the fluid is not constant; it's changed at any point. So we need to change this. We know that the acceleration, okay, a is equal to v over t kan. Okay, the velocity over time, the rate of change of velocity. Okay, so that's where we have F now equal to m over delta v over delta t lah. Okay, like this, macam ni. And we know that in continuity equation we have learned mass over time, okay, is what we call as mass flow rate, m dot, the dot. So this can change to m dot. So finally this equation will become something like this lah. So this is your final equation of the linear momentum equation. So we have the m dot times delta v, and we know m dot, the mass flow rate, is equal to rho q. Okay, m dot equal to rho q n. So we can write the equation as the F equal to rho q delta V. So this is the linear equation lah. When we solve this question, we will use this linear momentum equation. Okay. If you have any question, just ask. Okay. So this equation is called linear momentum or force equation, where the summation of F is the net forces subjected on the control volume, whether it's pressure or reaction or body. Okay, and the rho Q delta V, the rate of change in momentum in the control volume. Okay, so simple je lah. In theory, linear momentum based from the Newton's second law, and we adjust that a little bit because we are dealing with a fluid, water or oil, or whatever lah, fluid, not a fixed object. Okay. And because force ni kita tahu is a vector velocity kan, force and velocity ni is a vector quantity, so they have a direction, okay, in x or y or z. Okay, so that's why you need to write this linear momentum equation in each direction lah. Okay, in x direction, okay, in x direction, rho q, the velocity v. Why we have v2 and v1? Because the original equation is delta v kan. Okay, so the change in velocity, okay, that's why you have v2 x minus v1x. Okay, similarly lah to y and z, the v2y minus v1y. Okay, so you have to write the equation in all direction, depending in that case lah. Okay, direction. Okay, if there is only x and y, you just write x and y. If there is x, y and z, so you have to write x, y and z. And to find the resultant force, okay, so samalah macam dulu kita pernah belajar dulu resultant force, you need to add both force in all direction. Okay, if you only have two direction, x and y, okay, square of that in x direction and plus the square in y direction, square root of this will give you the total resultant force. Okay, so this is total resultant force. Okay, and to find the direction, okay, where this resultant force is acted upon, so you can find the angle, just inverse tangent the force in y direction over force in x direction. So ni quite similar lah to when we learn in chapter 2 hydrostatic force kan, you want to find the resultant force. Okay, and finally, because of the we dealing with a fluid, okay, the velocity of that fluid, okay, is not uniform, so it can be changes lah in one point compared to other point. You have maybe at this point the velocity of the fluid is 5 meter per second, but when it move and reach at other point, maybe the velocity is 4.5 depending on the orientation lah. So that because of that, okay, because of that velocity is not uniform, so that's why we need to introduce, they will have a dimensionless correction factor beta. Okay, you need to multiply with this number for your velocity. So in a question they might give you maybe beta is equal to 0.3 or 0.2 depending on the question, or they might not give you anything. So if they not give you anything, that means they assume the velocity is uniform. Okay, you can just use the velocity. If they provide you with this number, the beta number, so you need to multiply that with your velocity lah. So finally the equation will write like this lah, rho q times beta v2 squared minus beta v1 x. Okay, so it's not squared x. So this correction factor just because the velocity across is not uniform. Okay, right. Okay, yes.
Kalau yang direction tu kan tan inverse Fy over Fx
Okay.
kan. Kalau ada Fz dia still guna Fy dengan Fx je
Ha.
tak? Ke sama je?
Betul.
Okay.
Okay, thank you. Alright, we move on. Okay, whenever you find a problem regarding linear momentum equation, okay, how to solve the equation, you can just follow this procedure lah, one by one, step by step. Okay, in any problem, in any question, always the easier way is just follow step by step. Okay, what you need to do first, and then you can solve the question. First, you need to identify the control volume. Okay, in any question, they will give you a pipe ke or pipe bank ke, so that's your control volume lah. Okay, and you need to establish your reference axis. Okay, where is your reference axis? You need sometimes they give you in the picture, or sometimes you need to draw your own reference axis. Where is your positive and where is your in x direction, or where is your positive in y direction. Okay, you need to label that. Okay, that's the second step. The third step is identify and show all the FBD inside that control volume. Okay, sama je macam kita buat chapter 2 dulu. You have to identify and label lah all your forces inside that control volume, whether it's a W or whether it's a pressure. Okay, so you need to label that, because when you want, if you don't do that, when you want to write your linear equation, you cannot see where apa yang ada dalam equation ni kan. So that's why you need to identify and show your FBD. Okay, and so this pressure force P times A acts against the control volume, okay, unless the fluid is released into the atmosphere. Body force W, so this is P, pressure force adalah P times A, body force W. Okay, the weight, if they give you a weight of that pipe of the fluid have some weight, and you need to consider this force, the weight. If they don't give you any weight, or they say you can assume it's negligible, so there's no W component. Okay, and you have your reaction force lah, whether it's up in X direction or in Y direction lah. Okay, RS ni RX dan RY ni sama macam ni lah, sama ni lah yang ni. Okay, your FX and FY. Okay, I use R. Okay, so this is just the same thing. If you don't confuse what is R, okay, I just use R because reaction force. Okay, so RX or FRX. Okay, whatever you want to use. Okay, in X direction and also in Y direction. So you need to label that as well. And then you show the direction of the velocity of flow, because we are talking about the fluid flow inside a pipe or inside a duct. So you need to show that direction, which velocity flowing whether it's enter at this point and leave at that point, or whether it's enter from that point and leave to that point. Why? Because why we need to label this? Because we know from our equation, okay, you have the delta V the change in velocity. So you need to know the V2 and your V1. So that's why you need to label your V2 and V1. Kat mana dia masuk? Dia masuk tu V1 lah. And kat mana dia keluar, that's the V2. Okay, so that's why they ask you to show the direction of the velocity of flow. And the fourth step, so using the data, okay, apa-apa yang dah bagi dalam question tu, so you can write your linear momentum equation. Summation of F, okay, rho Q delta V. Okay, so add all everything that you have labeled, okay, and to write your linear momentum equation. Okay, you will find lah apa ni tambah ni ke apa, your equation. And lastly, then you substitute all the value inside your equation to solve the problem lah, whether they want to find normally they ask you to find this lah, to find this resultant force kan, whether in X or Y direction. Okay, so that's the theory on linear momentum, and this linear momentum equation will be applied on a different application. Okay, there are 4 different application that mostly this linear monitoring equation is used. Okay, one, the flow around a curved vein. Second, flow around a pipe band. The third, flow impact on a plane surface. The fourth one, flow passes through a nozzle. So we will look one by one today, how we can apply this linear monitoring equation to solve in this different application. Okay. Okay, first the flow round a curved vein. So this is the curved vein. Okay, there's a gray block. Okay, so this is the vein. Okay, this vein will deflect, kan? It will deflect the flow, this fluid the water ke oil ke. So this flow will deflect because you have this vein. Okay, so the flow will akan macam tu lah, akan bergerak macam tu, kan? Okay, so that is means by flow round a curved vein. Because this vein is curved, that's why the flow will deflect at angle lah, ikutlah. Okay, so in order for the curved vein to remain stationary, okay, because this vein is air tu langgar dia, kan? Air tu mengalir dan langgar that curve, and to make sure this curved vein is remain stationary, there must be a reaction force lah exerted against this flow, kan? So this is why your reaction force in x direction, okay, directed to the left against this flow, and your resultant force in y direction, in this direction. You can double check this direction after you calculate the value for Rx and Ry. If you get negative, that means your assumption is just wrong. So that means the reaction force is acting opposite direction. So that's the meaning of the negative value when you calculate the resultant force in X and Y. Okay, so don't worry if you calculate dapat negative, value dia negative. It just means that your assumption of direction is wrong. It's just the opposite direction. Okay. Okay, there's a flow around curved vein. Okay, we look example. This example 1, a basic example. Okay, it says a 25 millimeter diameter jet of water having a velocity of 6 meters per second is deflected 90 degree by a curved vein, as shown in the figure. The jet flows freely in the atmosphere in a horizontal plane. Calculate the x and y forces exerted on the water by the vein. Okay, so they ask you to find the Rx and Ry. Okay, so they give you the reference as is already in this picture. So they take to the left is positive and upward is positive. So this is your reference. Alright, and as the steps show you, you need to label all the forces inside this diagram. So your velocity in, okay, they gave you the velocity 1, 6 meter per second, and the velocity 2 out of this jet. So they did not give you the velocity 2, okay, but you can find out this velocity 2. Who knows what is the velocity 2 inside this jet? Siapa-siapa nak try? The value of V2. So they did not give you any V2. They just said the jet water velocity of 6, masuk ni yang 6. So this is 6 meter per second. Okay, apa velocity yang keluar? Does anyone know?
Six juga Pak Sen.
Why?
Sebab
You are right. The answer is 6, but I just want to know the reason why you choose 6. it is related to this pipe. Apa yang sama? Apa? Yeah.
A1 V1 equal
Ah.
to A2 V2.
Yeah. Sebab dia kata this jet 25 mm across, semua ni 25 mm lah. Maksudnya the area is the same. So that's why your velocity is the same. Okay. If they give you ada sini diameter lain, sini diameter lain, then your velocity will be changes lah kan. Okay, because of the area is the same, so that's why your velocity is just the same lah. So betul lah awak cakap tu. Velocity dia sama kan. Okay. Alright, so then write your linear momentum equation as this, because they give you the reference as this. To the left is positive. Okay, that's why they put here to the left positive. Summation of force in x direction equal to the rho q delta v. So v delta v we know v2x minus v1x. Okay, and we know v2x is 0 because there is no component in x direction. Okay, alright, and but we have a v1x. Okay, this one v1. But because your V1 is in opposite direction to your reference axis, so that's why they put minus V1 minus V1. Ada dua minus kat sini kan. Okay, this minus because your direction is against your reference. So that's why it's minus V1. Okay, so minus is plus. So that's why you get the final equation will be the reaction force in x direction, because it's only ada tu je kan, ada R je, tak ada pressure ke, tak ada W ke, tak ada, it's only x, Rx je, the reaction force that will yang akan lawan dia kat sini. So that's why, and then you can find your Rx just from this equation, rho times Q times V1. Okay, and you have everything lah for this. And similarly, you write. Ada nak masuk dia. Ada sebentar. Okay. So you have to need in y direction as well. So y direction, they give you the reference axis to the upward is positive. Okay, upward positive, summation of y. Ada siapa yang tak mute? Okay, thank you. Tengok ni ada gangguan sikit bunyi. Alright, thank you. Okay, is equal to rho q, alright, times v2y. The v2 in y direction minus v1y in v1 in y direction. You only have v1y, v2y, this one. That's why, and this one is same direction to your reference. That's why your v2y is only v2 lah. Minus v1y, and this is 0. There's no component in y direction for v1, so it's 0. So this will be rho q v2. Okay. And you have your property of all this value, the row of water 1000 lah. Okay, and you need to find your Q, and just using the continuity equation, the area times the velocity, and they give you the diameter kan. Okay, so you need to change this in area. Okay, pi r squared. Okay, so that's why that's where you get your Q. Okay, and just solve this equation. Rho ada, Q ada, your V1 pun ada, V2 pun ada, and you can solve the resultant force in x direction and also in y direction, and it's just the same. The values are the same. Okay, 18 kg per meter square per second square. Okay, sama juga dengan Ry. If they ask you to find the total resultant force, so you need to add this lah. Okay, 18 squared plus 18 squared. Square root of that is 18 lah. Okay, so that's example lah. One example in curve vein. Curve vein. So this is another example for a curve vein. Okay, but the vein now is look like this. Okay, canggih sikit, ada apa, at the angle. Okay, in a decorative fountain, so this is a fountain, 0.05 meter cube per second. So this is your, ni apa ni? What this tells you? 0.05 meter cube per second. Hello?
Q.
Mesh.
Yes.
Q.
Betul. Thank you. So this is your Q lah. Okay. Of water having a velocity of 8 meter per second. So this is your V. Okay, V1 yang masuk. Is being deflected by the angle should shown in figure given. So this dia masuk sini. So this your V1. Okay. And this your V2 keluar. Dia label dah sini. Okay. And they said determine the reactions on the shoot in the X and Y direction shown. So they ask you to find the resultant force in X and Y. Also calculate the total resultant force. Okay, this one they ask you to find total resultant force and the direction and the angle as well. Okay, neglect elevation changes. Okay, so they give you already the reference as this. So this apa, to the left positive and to the upward is positive. Okay, so this is your V1 . So from this you need to label as well your V1 in X direction and also in Y direction lah, because you have this angle kan, apa, 45. Okay, this is 45 angle, so this is 45 lah 45 degree. Okay, and similar to your V2, so you have your V2 in Y direction, V2 in Y direction, and you have also in X direction. You need to find the angle here lah, angle kat sini pun boleh. Carilah, dia bagi sini 45, 60. So that means this is, tahu kan macam mana cari kan? I hope you apa, just minus 180 minus this 5. So this will be berapa? 75 75 kan? 60 105. Betul lah.
Betul sir.
So this will be 75 and this will be 15. Okay, because it's 90. Okay, so you need to know that. Okay, so that's why they draw here. Okay, I just show you why you have this 45 and 15. But you know this is 75 kan? Tadi dah kira tadi kan? That's why you have 15 here. Okay, so you have the V1 in X direction, V1 cos 45, and in Y direction, V1 sin 45. Equally to V2, you have in your X direction, so V2 sin 45, and in Y direction, V2 cos 15. Okay, and you have your reaction force lah. Okay, in X direction, apa, to the right, to the left is positive, and upward is positive. So this is your reference as this. Okay, then you need to write your linear momentum. Okay, to the left is positive, summation of F in X direction, so rho Q times V2X minus V1X. Okay, and for forces you only have the reaction force lah. Okay, there's no pressure ke, there's no weight ke, there's not mentioned in the question, so just a reaction force kan. So Rx, okay, equal to the rho Q, the V2X is ini kan, V2 sin 15 but because it move opposite to your reference as this, that's why you put a minus sign. So minus V2 sin 15 minus V1X, and your V1X is this one V1 cos 45. Okay, this is your V1X, and because again it move in the opposite direction to your reference, that's why they also have a negative. Okay, so rho Q take out the V, but the V is just the same, but this also the same diameter of the benda ni, pipe ni. So that's why they take out the V. So V2 V1 ni sama je. Okay, minus sin 15 plus lah, because it's minus is plus, cos 45. So you will get this value is 0.448 rho times Q times V in X direction. Buat juga untuk Y direction. Okay, because you have two direction, Y and X and Y. Okay, to the upward is positive. So summation of force in Y direction equal to rho Q V2Y minus V1Y. There's only one ada term untuk reaction force je dalam force. Okay, that's why you only have Ry. There's no pressure or no weight. Okay, so rho Q times V2Y is this one. Okay, V2 cos 15. This is your V2Y, and it moves similar direction. That's why it's positive. Minus V1Y, and because V1Y move downward. Okay, V1 sin 45. That's why it's negative. So this will be plus lah. Okay, so rho QV times cos 15 plus sin 45. So this mentioned here because the cos stationary is the same. That's why your V2 and V1 is just the same. Okay, so you can check your data, your rho of water, your volume flow rate is 0.05 given in the question. Okay, and the V, the velocity also given 8 meter per second. Then you can solve your linear momentum equation. Rho times Q times V and times your ni apa yang cos tu kan, sin tolak ni, this one 0.448. Okay, and solve for Y as well. So you get the value for both direction X and Y, and to get the total resultant force, because they ask you to calculate the total resultant force, just ni lah R square plus RY squared, kan? Okay, square root of them, this will give you the total resultant force. Okay, FR, and to find the angle, the direction, inverse tangent, okay, RY over RS. Okay, you will get the answer lah. Okay, boleh faham sampai sini dulu? Anything you want to ask?
Sir,
Yes.
reference angle tu dia bagi ke kita buat sendiri?
Reference angle. Mana reference angle? Nombor satu.
Y.
Mana?
Reference exist.
Ni. Ni sebab dia dah bagi.
Oh.
Dia bagi
Kalau
sini.
Kita buat ke tak?
Kalau tak ada, you can do your reference axis lah, whichever you want. Whether you think your reaction force in X acting to the right, so you label lah RS to the right. Okay, or in Y, maybe you think your Y tu ke bawah, boleh je. Okay, but when you calculate this, you will get your value is negative. You will get this when you calculate ni. Bukan ini, contoh yang ni yang ni. So when you calculate, you will get the value is negative. So when you get the value is negative, it's not wrong. It's just you need to say is in the opposite direction. The arc should be should be in this direction, not in your first assumption. Faham tak?
Okay, faham sir.
So if they give you like this, ini pun mungkin je salah kalau dia bagi dalam soalan dia bagi macam ni kan. Maybe when you calculate dapat negatif kan. So this direction should be in your direction lah, in the opposite direction lah. Itu je.
Okay, faham.
Okay.
Terima kasih sir.
Right. Okay, that's first application, the flow round a curved vein. Okay. The second application is the flow round a pipe bend. Okay, this is your pipe and the pipe is bent. Dia dibengkokkan kan. What angle lah. So to ensure this proper installation of pipe, okay, akan fluid mengalir kan. Ada fluid mengalir masuk dan keluar. Okay, to make sure this pipe is steady, okay, hold in equilibrium. So there must be a force exerted in this, whether in this direction or that direction, depend lah. Okay, depend on the value that you calculate, but there must be an resultant force that will hold this pipe. Okay, normally in this direction lah, because if you have the flow coming from here, that means there is a force to the right. So that's why you need a reaction force against that to make sure it is hold in equilibrium. So that's why your reference axis dia buat macam ni. This is your reference axis, because they assume the R will be acting like this, and the Y will be acting like this. Okay, but it depends whenever you calculate. If there is positive, then your assumption of direction is right, but if it negative, then the assumption of direction is wrong. Itu je. Okay, so this is flow. We will look example of flow around a pipe bend. So this is a pipe bend. Okay, calculate the force that must be exerted on the pipe. Okay, shown in the figure given to hold it in equilibrium. The elbow is in a horizontal plane and is carrying 3000 liter per minute of water. Okay, so this is very important because this is your, what is this 3000 ni? Apa nilai ni? Your what?
Q Master.
Q. But this is in liter per minute, so you need to change that in meter cube per second. Okay, the volume flow rate is always in the standard unit, so you need to change that in meter cube per second. So then they give you the inlet pressure is 550 kilopascal. So you have the inlet pressure comes in. This is why they label P1A1. Okay, and they akan ada juga P2A2 yang akan against this. Okay, so you need to label that. So you have your V1 comes in, V2 comes out, and you have your inlet pressure P1A1, inlet force P1, P times A is force kan, because you write this is the term of force kan. So this is the force. That's why P1 times A1, pressure equal to force over A. So that's why it writes here P times A to get your force, this pressure force. Okay, so you have your P1A1, you have your P2A2 against, and you have your reaction force, and they give you the reference axis macam ni, ke kiri is positive, ke atas is positive. So you label like this. Okay, so in x direction, write your linear equation in x direction. So summation of force in x direction equal to rho times q times velocity 2x, velocity 1x. So you have V2 and V1. Okay, so force apa semua term force in x direction, you have Rx and you have P1A1 kan. Okay, and because you take to the left is positive, so Rx, okay, this is positive, minus P1A1 because P1A1 is moving to the right hand, so that's why you minus. You need to add everything kan, it's a summation of force, so you need to add this and add this, and because this one is moving to the right, so that's why it minus P1A1. Okay, so this, okay, there's only the force term in your x direction, so this will be equal to rho q, V2x is 0, okay, there's no V2x, and minus V1x, we know V1x is V1 and it is moving opposite to your reference axis to the right, so that's why you minus V1. Okay, and you rearrange the equation to get your resultant force in x. Okay, bring this P1A1 to the right hand side, you will get rho q times V1 because this is positive, plus P1 times A1. So this is your linear equation in x direction. Finish that one. Do for y direction, sama juga. Okay, add everything, a force term in y direction, you have Ry, okay, to the upward is positive, and you have P2A2, but this is moving downward. Okay, that's why is minus. Okay, Ry minus P2A2, equal to rho Q V2Y minus V1Y. V2Y is this one and it's positive, is V2, and V1Y is 0, there's no V1Y. So that's why only rho Q V2, and bring this to the right hand side and you will get your Ry equal to rho Q V2 plus P2A2. Okay? Okay. But the problem is, in this question, they did not give you the P2. Kan? Okay, they gave you the P1 equal to 550. Okay, but they did not give you P2. How to get P2? Macam mana nak cari P2? Anyone want to guess? Want to try? Ada cadangan? Ada cubaan? How to get P2? What we learned before, whenever you want to find the pressure, what equation that you use? Ingat tak? Yang panjang tu. Apa equation yang panjang tu, yang P1 tambah rho Q rho G plus Z1 apa?
Bernoulli.
Yes, we will use the Bernoulli equation lah to find the pressure, kan? Okay, that's why you need to find the P2 first. Okay, in this question, okay, P1 over rho G, okay, plus Z1 plus V1 squared over 2G, okay, equal to P2 semua tu, kan? Okay, and Z2 plus V2 squared over 2G, okay. But in this case, okay, another trick is that because it is the same cross-sectional area again, okay, so the area for inlet and the outlets is just the same, so the P2 is actually just the same with P1, okay, 550. Okay, if this part is something that you have a nozzle, ada berubahlah bentuk dia, it's not different, it's not the same. So that's where you need to use the Bernoulli equation. We will look after this. There's an example for that. Okay, but in this case, the pressure is just the same as P1, 550, and the rho is 1000, and the Q, okay, the Q they give you 3000 liter per minute. I ask you, you need to know how to convert this in meter cube per second. Okay, that's why they divide by 60,000. Okay, liter per minute. 1 minute is at 60 seconds. Okay, and 1 liter, this is liter, so this minute, okay, and liter kat bawah, and this is meter cube. Okay, so this is 0.001. To get to change liter to meter cube is 0.001. That's why you get 60,000 lah. Okay, so that's how you change liter per minute into meter cube per second. Okay, that's why you get 0.05 meter cube per second, and you can find your V from the continuity equation. Okay, V1 berapa? You have your Q and you have your area. They give the area ke sini? Oh, tak ada pula. Macam mana dapat ni? I think there's a typo. Okay, they must be give you the diameter ke kat sini? Should give you the diameter of this pipe berapa? Okay, from that diameter it will give you the area lah. This area. I think this must be typo kat sini, kat soalan ni. Tak ada bagi nilai diameter, kan? Okay, so that's how you get your V, and then you can solve lah your linear momentum equation. So Rx rho times Q times V1 plus P1 times A1. Okay, they must give you the A1 here, the diameter here, diameter of this pipe. Okay, to get the area. Okay, so you just substitute back inside your linear equation, and this will give you the answer for resultant force in X direction. Okay, and also in Y direction lah. Okay, this is the Y direction. Okay, and then if they ask you the resultant force, dia minta ke? Okay, okay, so they ask you to calculate the force, the force dia. So in X direction and Y direction lah, in both. So you already get your answer lah in X and in Y. Okay, so they don't ask you to find the resultant force, okay, and the angle. So that's a second example of linear momentum equation where you apply pipe band. Ini pun pipe band juga. Second example for pipe band, flow around a pipe band. So this is your pipe, and you have the pipe is bent. Okay, macam ni. Okay, this is your velocity in and velocity out. Okay, and it says converging elbow as shown in figure turns water through an angle of 135 in a vertical plane. The flow cross section diameter is 400 mm. So they give you the diameter for this inlet 400 mm and 200 mm at the outlet. Okay, so there's a different cross sectional area. It's not the same. The water volume flow rate is 0.4 meter cube per second. So this is your Q for 0.4 meter per second, and the elbow inlet and outlet pressure is 150 kilopascal and 90 kilopascal. So they gave you already the P1 and P2, okay, 150 and 90. The mass of the elbow and the water in between section 1 and 2 is 200 kilogram. So that means you have W force. So they give you the mass of the elbow and the water. So there must be term W ke bawah lah. Force weight always go downwards kan. You have your weight. Okay, and then determine the force in horizontal direction. They ask you to find the Rx and the force in vertical direction Ry, and the magnitude of the resultant force and also direction. Okay, so they give you the reference axis. To the right X ni positive and upward is positive. Okay. Okay, when you label your free body diagram, okay, you have your V1 comes in, and you have your P1A1 comes in as well to the right, and you have your W downwards, and you have your V2 comes out, and you have your P2A2 against this. You always add against, unless it release to the atmosphere. So this is why your P2A2 is acting against this. Okay, and then you can write your linear momentum equation in X direction. Okay, you have P1A1 is positive. Kat sini positive kan. So it should label kat sini to the right is positive. Okay, you have your P1A1, and you have this P2 have another component, ada ke atas dan ke kanan. Okay, so this is you have the angle here. Okay, this will be P2A2 cos theta. Okay, let's say this is theta. Okay, and this will be P2A2 sin theta. Okay, and this theta you can find out lah from here. So this is ni 135, maksudnya ni ialah berapa? 45 kan, 45 degree. So your angle here is sini 45. Ni 45 lah maksudnya angle ni 45 lah. Betul?
Betul sir.
Okay. So you need to know this, okay? because you will use this angle in your calculation kan. Okay, so this will be P2A2 cos theta, and this will be P2A2 sin theta. So that's why you add, because this P2A2 cos theta is in the same direction to your reference axis. Okay, so P1A1 plus P2A2 cos theta plus Rx this Rx lah. Okay, you want to find kan Rx ni. Okay, equal to the rho Q V2X. Where is your V2X? So this is V2. V2 pun ada dua komponen, satu ke Y, satu ke X kan. Okay, so you have your V2 in X direction will equal to V2 cos theta, and because it move in the opposite direction to your reference, that's why it's negative, minus V1X. Okay, V1X is this one, okay, in the same direction, so that's why only minus V1 lah. Okay, and you rearrange your equation, put everything to the other side, just leave with your resultant force in X direction. Okay, so rho Q times negative V2 cos theta minus V1 minus P1 times A1 minus P2 A2 cos theta. Okay, this is your in the momentum equation in X. Do the same for Y. Okay, summation of force in Y direction, so you have to check your Y direction. So you have P2A2 sin theta, okay, in one direction, and it is in the same direction to your reference axis, minus W, because W going upward, downwards, okay, minus W, plus the Ry, okay, this will be equal to rho Q V2Y minus V1Y. V2Y is this one going downward, okay, yang ni V2 sin theta. That's why you have negative V2 sin theta, and V1Y is 0 lah. Okay, so you rearrange that to get your Ry will be equal to rho Q minus V2 sin theta minus P2A2 sin theta plus W. Okay, so this is your equation lah. Okay, this is very important to get the right linear momentum equation. Okay, and then check your data. They gave you the P1 equal to 150 kilopascal. Okay, take note this is kilopascal, so you need to multiply by 1000, and P2 90 kilopascal, and you have the mass is equal to 200 kilogram. Okay, 200 kilogram, and you have your Q equal to 0.4. Okay, give you 0.4 meter cube per second. Okay, and from continuity equation you can find the m dot. Okay, the mass flow rate, because you have the mass and you have the Q. Okay, so rho times Q will be equal to the mass dot, m dot. Okay, this will be 400 kilogram per second. And to find the V1, because they did not give you the V1 and V2 kan, they gave you the diameter, the area A1 and A2. Okay, so you can find your V1 and V2 from the continuity equation. Okay, so you have m dot 400. Okay, divide by this. If you bring all this to the bottom, m dot divide by rho times V times A, you will get your V1 lah, and rho 2 divide by A2 and rho, you will get your V2. Okay, so this will be awak pun boleh juga cari dengan, kalau nak guna to find V, you can also use the Q over A lah. Okay, boleh juga V kan. Okay, in this case they use this using the m dot, because they find the m dot first and then divide by that, we get the velocity. Okay, it's just the same Okay, but the point is to find the velocity at 1 and also at 2. Alright, so you get your velocity 1 and velocity 2. Then you can solve lah your equation. Okay, this is your equation for in X direction. So you have your rho, you have your Q, you have your V2, you have your V1, you have P1, you have A1, you have P2, you have A2. Just substitute back, and okay, see here the value is negative. Okay, when the value is negative, that means, alright, your reference axis ni yang ditulis ni to the right is positive kan. So this is wrong lah. It should be to the left. Okay, that's why you can write your answer like this, or the value of that 25,725.9 Newton. Just put in bracket the direction should be to the left, opposite to what you assume first. You assume first the reference axis, first assume to the right is positive. Okay, so that's only lah. So don't worry about the negative sign if you get negative. Okay, sama dengan y, just substitute back in y, in linear momentum equation in y, and eventually you will get the value also negative. Okay, so that's mean again the assumption for your direction yang y ni ke atas is wrong. It should be going downward. Okay, the ry should be going downward lah. Okay, so that's why they write the final answer as 3636.3 Newton in bracket arrow downward. This to tell your direction. The right direction should, I think, downwards. Okay, and to find the resultant force, just add lah both of these. Okay, square of this and square root of that. Okay, you will get your total resultant force, and to find direction, inverse tangent. Okay, okay, that's the second application. Any question before I move on to the third application?
Setakat ni tak ada.
Okay, don't worry if you yes.
Kenapa kita kena masukkan W je?
Kenapa kita kena masukkan W? Kenapa kena masukkan?
Sebab kat curve vein tu dia W tak ada.
Okay, that's a good question. Before this, in curve vein apa semua ni, they did not give you the weight. Okay, tak ada mention apa-apa pasal weight kan? Betul? So there's no weight lah. Maybe the weight is small. Adalah weight kan? Ada weight of water, ada weight of this pipe juga kan? But maybe is not significant. So that's why they ignore that part of W. But in this case, in this example, they provide you with the W. Mana dia? This one. So in this example, they give you the weight because maybe the weight is quite significant. 200 kilogram. And this pipe and this water maybe is quite big, and that's why they have this W component. Okay? Boleh ke? So it depends lah on the question. If they provide you with the weight, so you need to consider the weight. If they don't mention at all the weight, or they said the weight of this pipe is negligible, so you don't have to consider the weight lah, W. Okay? Alright. Mana? Okay, the third application is the flow impact on a plane surface. So you have a plane surface yang ni. Okay, you have your plane surface, and you have a water jet hit this plane surface. So this the flow impact hit this plane, and this water will split lah. Ada ke atas, ada ke bawah kan. Okay, selepas dia hit that plane, then the water will split. Okay, so in order to make sure this plane surface remain stationary, we need to have a reaction force acting on this surface in opposite direction to the water jet. Okay, if not, this plane will move, start to move lah because you don't have this reaction force kan. So that's why you have this reaction force against the water jet. Okay, so that's the theory lah. So we look example of that water jet hitting a plane surface. So it says here, water is accelerated by a nozzle. So you have a nozzle where your fluid comes out to an average of speed 20 meter per second and strikes a stationary plate. This is your plate at a rate of 10 kg per second. So this is your kilogram per second. apa ni, kilogram per second is
Mass flow
mass
rate.
flow rate. Okay, m dot n, continuity equation. So it's always related to continuity equation, to Bernoulli equation, because that's why it's the same chapter kan, chapter 3. Okay, with a normal velocity of 20 meter per second as shown in figure given. After the strike, after this water strike this plane, the water stream splatters off in all direction. Okay, in this go down and go up. Okay, determine the force needed to prevent the plate from moving horizontally due to the water stream. So they ask you to find this reaction force in order to make sure this plane surface is not moving. Okay, so this draw your FBD. You have your V1 and you have your reaction force, and you have your V2 lah, goes up and down kan. Okay, then there's no pressure. Okay, it's not mentioned any pressure or weight. Okay, so you can ignore that, right? And then you write your linear momentum equation in x direction. Okay, and they give you the direction in x to the right. Okay, and upward positive y. Okay, so that's why positive to the right, fx equal to rho q v2x minus v1x. In x direction you only have the fr, and this fr is okay, again if look here, y is negative. Okay, because it's, even though they have draw this reference as this, to the right is positive. So the reaction force that they assume, the reaction force that assume against this plane surface should acting to the left hand. That's why it's minus Rx. Okay, if they assume to the right macam ni, Fr, so you don't need to put minus lah, but logically the Fr should be acting to the left hand in order to make sure this plane surface not moving. Okay, that's why they put minus Rx equal to only that only one term je in term of force, there's no other term. Okay, so equal to rho q v2x is 0. Okay, there's no v2x minus v1x. Okay, v1x is the v1. Okay, and it moves in your same with your reference axis to the right. So that's why minus v1. And this rho q is your m dot. Okay, and you can write as equal to m dot times minus v1x. That's why they give you the m dot here. Okay, so you can use just that value in your linear momentum equation. So that in x direction, and you need to do in y direction. But in y direction, of course, everything is 0. Okay, there is no reaction force in y. Okay, so that's why there is no linear momentum in y direction. Okay, and check your value. The v is 20, gives to you 20 meter per second. Okay, v2x is 0, so you can solve your linear momentum equation. M dot is 10, v1x is 20, so this will be minus 200 Newton. Because you already put your equation like this. Okay, minus Rx equal to minus 200 Newton. Okay, then this can be cancelled out. So that means your direction for this is right lah. Okay, the Rx should be acting to the left. So it's not x 200 Newton. Okay, alright, so that's the third application. Any question before I move on to the last application? Ada soalan? Tak ada Okay, lastly, finally, the forces on a nozzle pipe. Okay, nozzle pipe. Okay, this is a nozzle pipe. You have converging cone where your velocity of the flow is increasing. Okay, a nozzle flow is usually contracted at the nozzle because the area, the diameter is smaller, so that's why the velocity will comes out very high lah. Okay, that's why you need to hold this nozzle because we have a force kan. Dia bagi contoh sini macam fireman fireman when they hold that nozzle to apa nak padamkan kebakaran, that water is very high in velocity because they have a nozzle in front. Okay, that's why they need to hold maybe 2 or 3 people will hold that to withstand this force. Okay, so this they give you example. The water is being fired at 20 meter per second from the hose. Okay, it go out 20 meter per second. Okay, of 80 millimeter diameter into the atmosphere. So this diameter is 80. The water leave the hose through a nozzle with a diameter of 25. So this exit nozzle is 25, and this inlet nozzle is 80. So this is 80 and this is 25. Okay, at its exit. Find the force on the nozzle. So they ask you to find the resultant force. Okay, and they label with here the reference axis to the right is positive, upward is positive. Okay, and then so you have your V1 comes in, and you have your P1A1. Okay, and you have your V2 comes out, and you have your reaction force against this. Okay, even though you this reference axis to the right is positive, but logically the force must be against that to hold that nozzle. So the resultant force normally will think to the left. Okay, and you need to write your linear momentum equation in x direction. So you have to the right is positive, so use your reference axis. Okay, you have your P1A1. Okay, and you have your Rx, and your Rx is acting in opposite direction to your reference. That's why you minus. Okay, rho Q V2x and minus V1x. V2x is V2. Okay, in the same direction, V2, and V1 also V1 in same direction as well. So that's why it's only V2 minus V1. Arrange your equation to get Rx. Okay, negative Rx here, they bring this to the right hand side. Rho Q times V2 minus V1 minus P1A1. Okay, and in this example that you need to find the P1. Okay, because they did not give you the P1. Okay, but we know this is a nozzle, so that's why you have a pressure comes in, pressure force P1A1, but you need to find that. In order to find that, that's where you use this Bernoulli equation. Okay, P1 over rho G. Okay, ni gambar ni rho G dah. So P1 over rho G, I write in my version, in my version that I teach you. So P1 over rho G plus Z1 plus V1 squared over 2G. Okay, is equal to the P2 over rho G plus Z2 plus V2 squared over 2G. Okay, you can find your V1 and V2 from the continuity equation. Okay, just use the QAV, so you get your V1 and you get your V2. Or V2 dah bagi dah 20 in the equation. Okay, bagi 20. Okay, and you want to find V1 from the continuity equation. So you get your V1 and you get your V2, and Z1 and Z2 because it's in the same elevation at point 1 and point 2, so you can cancel out the Z. Okay, so it's 0, and they give you the what else? Because of this is released to the atmosphere, and this hose, this fireman hose is released to the atmosphere, so that means your P2 is equal to 0. We need to remember this. Okay, so that's why your P2 is 0. Okay, so you can find your P1 from the equation. Just V2 squared minus V1 squared over 2G, and you can find your P1 times ni lah, bawa ni ke tepi lah so times rho g. Okay, so you will get your P1 equal to 198 kilopascal. Okay, when you get this, then you can put back in your linear momentum equation here lah. Okay, in for y in x direction. Okay, the value for P1, you have your rho, you have your q, you have your v, you have your p, you have your a, then you can solve your linear momentum equation to find the Rx. Okay, so you will get your Rx equal to 818.69 Newton. Okay, and this Rx is this this direction is right lah. Okay, because you get the positive value. Okay, so the assumption of this Rx in the to the left is right. Okay. Okay, so this angular momentum we discuss tomorrow. So any question regarding linear momentum and their application? Ada soalan? No question?
Sir,
Yes.
macam mana nak tentukan direction force dia?
Okay, you mean this one? So sorry. Okay, you mean how to yang ni maksud awak?
Direction dia, macam tu.
This direction you can assume je whether it's to the left or to the right. You can choose any direction you want to assume. Basically, okay. So but in logically speaking, if you have a nozzle like this and that nozzle akan ada force yang keluar macam ni kan ke sana. So in order to make sure is in equilibrium, mestilah akan ada direction force yang akan against dia kan. So that's why in this question they assume to the left. Okay, but it doesn't matter actually. If you assume to the right pun boleh je, and when you calculate, you must get the value negative. So you just write lah, your assumption is wrong. The direction should be to the left. Boleh?
Okay. Thank you, sir.
So that's why they establish this reference as this. Okay, this reference as this. If you took to the right is positive, apa-apa yang opposite tu negative lah. Okay, if you the right to the left kan, so this y is negative. Okay, so this reference as this is important lah. So that's why they gave you in the step by step to establish this reference as this. Either they gave to you in the question, or they did not give you in the question. You need to establish your reference as this. Okay, sama juga dengan contoh yang ni, plane surface. Okay, there's a water strike this plane surface. Okay, so logically speaking, mestilah akan ada force yang akan against this force kan. So that's why they assume the F rod ni to the left. Okay, but you can also assume this F rod to the right juga, tak salah pun. But when you calculate, you will get the values the same. It just is whether negative or positive je. Itu je lah. Okay.
Kalau yang ada 200 kilo tadi tu, sir?
200 kilo. And this one.
Ini.
Okay. So your Rx, okay, in this example they took similar to your reference. Saya padam dulu ni. Okay. So in this example, okay, the Rx they assume is in the same direction to this reference as this. Okay, so they assume the Rx ni ke sana lah, ke kanan. Okay, and the Ry ke atas. Okay, so again it doesn't matter in which direction you assume, if they assume with the same reference as this, so that's why it's positive lah. So you have your P1A1 and you have your Rx. Okay, you need to sum, because this is summation kan, summation of force in X direction. So you have your P1A1 and you have your Rx, and you have your P2A2 cos theta. Ni pun ke kanan juga kan. That's why they add everything, P1A1 plus P2A2 cos theta plus Rx equal to rho Q semua ni, and you will get this equation. And when they calculate, the value is negative. Kat sini, saya padam dulu ni. Okay. Okay, when they calculate, they get the value for the resultant force in X direction is negative. Okay, so that's what I said. Doesn't matter in which direction you get, in which direction you assume. When you calculate, when you get the negative, that means this direction is wrong. It should, the resultant force acting on this elbow should be to the left. Patutnya dia akan kat sini lah dia bertindak, patutnya dia RS ni and awan elbow ni kan. Betul tak?
Betul sir.
So that's why don't worry too much on which direction should I take for the resultant force for this when you write your linear momentum equation, but just establish your reference as this. Okay, that's why they give you this reference as this. To the right is positive, to the upward is positive, and you label your equation. Okay, the Rx ni can be to the right, can be to the left. It will depend on your calculation lah. But for W ni tak boleh lah. W ni always acting we always acting downwards. You cannot label this W to upward kan. Okay, you cannot ni tak boleh, always downward. And P1A1 pun always to the right because it enters this pipe, P1A1, and P2A2 pun you always acting against this. That's why the arrow should be to inside the pipe. So that's why you have this value arrow for P2A2 to the right and to the upward. Okay.
Lepas tu nanti resultant force yang kita cari tu dekat lubang dia masuk ke lubang dia keluar?
Resultant force ni maksudnya kat sini ni, kat sini. Kan dia satu Rx, satu Ry kan. Y dia acting macam ni, Y dia acting downward So Y dia acting macam ni lah, downward. Okay. So the resultant force ni hasil resultant force yang dua ni. So sama ada macam ni lah, betulnya your resultant force FR acting macam ni. Ada angle dia kan. Angle tu yang dia cari, so cari angle kan. So this angle tu yang 8 degree lah. Okay.
Okay sir.
Alright.
Sir, yang angle tu antara FR dengan RS ke atau FR dengan RY?
Okay. Good question. Okay, in definition, okay, when you want to calculate, let me show you this one kan. Okay, you have let's say this is your Fx, okay, and this is your Fy. Okay, salah arrow je, salah. Kan? Okay. So this will be Fs, Fy. So this is your resultant force. Okay. So your question whether the angle is here or the angle is here. Kan? So what do you think from this equation?
Ya. Yang atas antara Fx dengan Fr.
Kat sini.
Betul ke sir?
Ni angle dia. ni tangent kan? Tangent. Okay, kalau you learn from this hypotenuse trigonometry ni kan, ni angle. Okay, this is your FR lah, this is your resultant kan, and this is your Y, and this is your X. Okay, so kalau you buat all macam ni, so this is your X and this is your Y, and this is your resultant. So this is the angle. Betul? Angle dia yang ni lah patutnya. Faham tak? Hello? Dengar tak?
Dengar
Ah.
tak dengar sekejap. Dengar proses.
So kan kalau kita belajar apa, kalau ni 3, ni 4, ni berapa? 5
5.
kan? Kalau you apa 3 kuasa 2 campur 4 kuasa 2 set dapatlah 5 kan? Kan? So
Ah.
get this angle, divide 4/3 kan? Tentang bagi sebelah.
Oh, okay, nampak.
Kan? So the
Ah.
angle is here lah. So between Y ni lah, Y ni. Kat sini angle dia. Bukan yang ni.
Oh, okay. Thank you, sir.
So ni sama macam chapter 2 kan, when you find your resultant force, the hydrostatic force kan, if you remember. Okay, and they ask you to find the angle as well kan. So inverse tangent Y over X kan. Okay,
Betul, sir.
alright. Any more question? Dah habis lah masa. 2 more minutes. Okay, anything else?
Sir, kalau soalan tadi yang pipe tu kan, ada ke soalan yang dalam pipe tu tapi dia gunakan apa ni dia punya density lain-lain.
Density of the fluid.
Maksud ada dua. Maksudkan dalam pipe tu kan dia kata air kan, ada ke soalan yang bila dalam tu dia punya cair tu dua tak beza?
Tak. Kena satu je lah. The row is always the one. Kalau the fluid tu satu je yang mengalir, sama ada water or oil. So the row tu cannot be changed lah, it's constant.
Oh, okay. Thank you, sir.
Okay. I think that's all for today. Thank you for your attendance. And again, just to remind you, tomorrow you get a deadline kan for assignment.
Yes, sir.
Okay. I realize few of you has submitted earlier in the classroom. Well done. But for those who not submitted yet, you still have time. Okay. And please submit before the deadline lah. Right. We shall meet tomorrow. Tomorrow we do more tutorial on this linear momentum, and we'll touch a little bit on the angular momentum. Okay. Right. That's all for today. Thank you very much.